Now we're going to look at the difference between equal sets and equivalent sets. So two sets are equal if and only if they contain exactly the same elements. They have to be, exactly the same in order to be equal. So if we have this set A, which contains 1, 2, and 3, those are the elements 1, 2, and 3. And then we have set B, which also contains the same elements 1, 2, and 3, then we say A and B are equal. The order does not matter, right? It doesn't matter what order they're standing in, it's still the same group of numbers. So we always use this symbol, equals, for equals, and it legit means equals. Equivalent is slightly different. It doesn't necessarily mean the same thing as equal. Equivalent, two sets are equivalent if and only if the elements can be placed in a one-to-one correspondence. So in other words, they just have to have the same number of elements. Oh, that's the kicker here. So set A contains the elements 1, 2, 3, and 4. Do you see how it's got 4 elements? Set B has the elements A, B, C, and D. That also has 4 elements. So since they have the same number of elements, that 1, 2, 3, 4 could be paired up with A, B, C, D, then we say A is equivalent to B. So we use these like squiggly equal signs. I mean, it's not quite equal, but they're equivalent. So let's try this with some sets down here at the bottom. So I've given you 5 sets. Some of them have numbers, some of them have letters, some have 3 elements, some have 4 elements. You can count up the number of elements in each set. So first we're just going to decide equal or not equal. So not equal would have the slash through it. So sets A and B. Well, A contains the elements 1, 2, 3, and 4. B contains M, N, O. I would say those are not equal. One is letters, one is numbers. A and B are not equal. How about A and C? A has numbers, C has letters. Now they have the same number of elements, but they're not exactly the same, so A and C are not equal. And then for A and D, A contains 1, 2, 3, and 4. D also contains 1, 2, 3, and 4, just in a different order. Those would be considered equal. How about the same game but equivalent or not equivalent? So they have to have the same number of elements. So let's look at B and E. B has M, N, O. B has 3 elements. I'm just going to make a note here. It has 3 elements. And E has 10, 11, and 12, which also has 3 elements. So they have the same number of elements. They are equivalent. How about A and C? A has 4 elements. C has 4 elements. So they're not equal to each other, but they are equivalent. How about A and D? A has 4 elements. D has 4 elements. Now you'll remember A and D are equal. That also means they're equivalent. So equal implies equivalent, but the reverse is not true. How about D and E? D has 4 elements. E has numbers, but it's not the same numbers, and it's only got 3. So these would not be equivalent. So it has to do with the number of elements inside the set, not necessarily what those elements are.